This is a partial fraction expansion question. And the denominator is already factored for you. You have x squared plus 1. So you need one fraction with x squared plus 1 as the denominator. And because this is a quadratic denominator, you have to put ax plus b. And then you have x plus 1. And since this thing is squared, you have to put x plus 1 squared as well. And we put c and d there. Although this is quadratic, this is a square of a linear polynomial. In that case, you just put a single letter. Okay, you don't put two letters. Are you fine with this? Okay.
Yeah.
Yeah. All right. Okay, then we have to figure out what a, b, c, and d are. These are specific numbers we have to figure out. We multiply this denominator to these three terms. And when this is multiplied to this first fraction, x squared plus 1 will cancel this x squared plus 1. So you are going to get ax plus b times the remaining part is x plus 1 squared. And then for the next one, c over x plus 1, when this gets multiplied to this one of the x plus 1's will cancel out away. So you're going to get c x squared plus 1 times x plus 1. And finally, when this gets multiplied to this one, you get d times x squared plus 1, because x plus 1 squared got canceled away. All right, and then this should be equal to 4x cubed plus 12x plus 4. What numbers can we plug in?
Negative 1.
Negative 1, because negative 1 will get, this one become 0, this one will become 0, but this will be 2d. So that if you plug in negative 1 here, it would be negative 4 minus 12 plus 4. Negative 1 cubed is negative 1. Negative 1 times 4 is negative 4. And then canceling these two out and dividing by d gives you d equals to negative 6. But then we run out of good numbers to plug in. Maybe 0. 0 would get rid of a, because a times 0 will be 0. But that won't be enough. You just get an equation between b and c. So there are several approaches here. You could plug in 0. You could also look at the highest order term. You can even plug in x equals to I, the imaginary number. If you do that, this will be 0, this will be 0. You have to do I plus 1 squared. That's certainly doable. Okay? You can use mix of these approaches to do it. But, you know, these multiplications are not too bad that you can just multiply them out and then try to compare the two sides. That's not too hard. So let's do that instead. And I can't really say which one's easier. Yeah, and I forgot about the other case. You can also differentiate both sides by x, and then you can plug in 0 or whatever. It's yet another way. So what I'm doing is not the most optimized one, but still it's good enough, okay? X plus 1 squared will be x squared plus 2x plus 1 plus c times, this will be x cubed, x squared, 1 times x will be x, and then 1 times 1 will be 1. D is negative 6, so negative 6 times x squared would be negative 6x squared. And then negative 6 times 1 will give you negative 6. Let's expand further. Ax times x squared will be ax cubed plus 2ax plus 2ax squared, and then ax plus bx squared plus 2bx plus b plus cx cubed plus cx squared plus cx plus c minus 6x squared minus 6. And then you want to organize by powers of x. X cubed is here and also here, so if you combine them, this is a plus c x cubed. Let's look at x squared. There's a 2ax squared, and there's a bx squared, and there's a cx squared, and then minus 6x squared. Then for the x term, there's ax, and then 2b, then there's a cx, and finally the constants are b, c, and negative 6. B plus c minus 6. And that has to match with this function. And for two polynomials to be equal as functions, what must happen? When two polynomials are equal as functions, it must be that?
Plug in any value of x.
Okay, so one thing is you can plug in any value of x and they should be producing the same number. That's what we are using here when we plugged in x equals to negative 1. But there's another thing that you can use, which is?
You can differentiate both sides.
No. Okay, so being able to differentiate both sides, that's yet again another property. If two sides are equal as functions, you can differentiate both sides and it's still equal. The third fact, which is what we want to use, is that their coefficients must match. So a plus c must be 4. A plus c must be 4. And 2a plus b plus c minus 6 must equal to? 0, because there is no x squared, right? And then a plus 2b plus c must equal to? 12. And then b plus c minus 6 must equal to? 4. And among these, you really don't have to use all 4 because you realize that you only have 3 unknowns and you have 4 equations. So, and that's because we already found D. So it's partially solved. And you know what? We know that b plus c must be 10, right? So we can use that to replace this one by 10. So that 2a plus 4 is 0, which means a must be negative 2. So we get a as negative 2, which means c must be positive 6. And finally, if c is positive 6, b must be 4. So you can just keep track of, once you find one thing, then everything just reveals itself. Okay, so what did we achieve? Did we get the answer?
No,
No, we just realized what a, b, c, d, and d are, we still have to do the integral. So here is what we found. We found out that 4x cubed plus 12x plus 4 over x squared plus 1, x plus 1 squared is equal to, a is negative 2x, and b is 4 over x squared plus 1, plus c is 6, plus d is negative 6, was it? Yeah, negative 6, right? I erased it, but it was negative 6. And using this identity, we can say to integrate this left side is same thing as integrating this right side. Let's continue on. We also want to break apart this fraction into 2 so that the first integral is negative integral of 2x over x squared plus 1 dx. The next integral is, it's 4 over x squared plus 1, but let me pull the 4 outside and write it as integral of 1 plus x squared. And the other ones are easy to integrate. This integrates to 6 ln of absolute value of x plus 1. 1 over x squared integrates to, negative 1 over x squared integrates to 1 over x, so this should be integrated to plus 6 over x plus 1. So we just have to do these two. Now, why did I put 2x over x squared plus 1? Why didn't I pull the 2 outside?
The 2x is going to go away anyway.
Why?
Because if you take the derivative of the bottom.
Because if you take the derivative of the bottom, you get the top. Derivative of x squared is 2x. Derivative of 1 is 0. So this is f prime over f type. What's the integral of that? ln. So it'll be negative ln of x squared plus 1 plus 4 times arctangent of x. And that's why I switched x squared plus 1 to 1 plus x squared, because that's the usual way arctangent derivative is written. And everything else is good. Okay, what am I still missing?
Plus e.
Plus c, thank you. That's it. That was a challenging question, I think. Let me try to do another partial fraction expansion, but this time it requires u substitution as well. So 1e x plus 3 square root of x plus 2 dx. You want to say u is equal to square root of x, so that u squared is x, and that allows you to replace this x by u squared and this by u, which looks a lot better, right? And then if I apply the d operator both sides, this is 2u du equals to dx. Derivative of u squared is 2u, and then I attach du. Derivative of x is just 1, so it's 1 times dx. And that's all I need to change this integral. This would be 3 over u squared plus 3u plus 2. Dx will become 2u du. And since if you multiply something to a fraction, it only gets multiplied to the top, it'll be 6u. And then this is still about partial fraction expansion. To expand into a bunch of fractions, you need to factor this, right? How does the denominator factor? What times what? U plus 1,
times
U plus 2. Okay. So that's what you need, and then that suggests I need to do partial fraction expansion of 6u over u plus 1 times u plus 2, which is a over u plus 1 plus b over u plus 2 for some unknown constants a and b. Again, we use the same trick, multiply this to the other side so that this becomes 6u equals to a times u plus 2, b times u plus 1. And for this one, it's easy. We can just plug in two values, right? U equals to -2. That gives you -12 equals to -2 plus 2 is 0, so that goes away, and -2 plus 1 is negative. So it's negative b, which says b must be positive 12. And when you plug in u equals to -1, this gives you -6. 6 times -1 is -6. -1 plus 2 is positive 1, so you just get a. -1 times -1 plus 1 gives you 0, so that goes away. So a is -6, which says I have the identity.
Can you not erase the bottom?
Okay. I have the identity 6u over u plus 1, u plus 2 equals to a is -6. It's -6 over u plus 1 plus b is positive 12. 12 over u plus 2. And after identifying the partial fraction expansion, we can integrate both sides. And these integrals are relatively easy. So you have -6 ln u plus 1 plus 12 ln u plus 2. Don't forget the plus c. And that's it.
No.
No, that's not it. Okay, good. Why?
To plug the u's back in.
Yeah, and then, yeah, u is square root of x, right? So don't be too delighted at seeing what seems to be the answer. You have to go back and replace the u by what you substituted with. U is equal to square root of x.